Ma'am, what happens if, instead of adding, we multiply each side of the inequality by the same number?
Yes, ma'am. What will happen to the inequality?
I'm glad you asked. Give me any two real numbers.
Ma'am, how about 9 and 5?
Okay, so obviously 9 is greater than 5. What number shall we multiply to both sides of the inequality?
Ma'am, how about 3?
Okay, so 9 times 3 is equal to what?
27!
Good. So how about 5 times 3?
15!
That's right. So is 27 greater than or less than 15?
27 is greater than 15. Oh wow! So if we multiply the same value to both sides of the inequality, the order will remain the same.
Well, we use the positive number to multiply by both sides of the inequality. What if we used a negative number?
Okay, let's try negative 2.
So what is 9 times negative 2 equal to?
Negative 18.
How about 5 times negative 2?
Negative 10.
Is negative 18 greater than or less than negative 10?
It's less than. Oh, the order of the inequality is reversed. So I was wrong.
Actually, you were partially correct.
Yes, what you said only works for a positive multiplier. If you use a negative multiplier, the order of the inequality is reversed.
That's a good observation, Christine. Let's try some more inequalities to be sure. Consider negative 3 and 2. Obviously, negative 3 is less than 2. Now think of the number we can multiply to both sides of the inequality.
Ma'am, how about 4?
Let's try that. And let's also try a negative number.
Ma'am, how about negative 3?
Okay, let's try that as well.
I'll do negative 3.
And I'll do positive 4.
Well then, come on down. Tell us what happened to your inequality, Chris.
Well, ma'am, the orientation remained the same when I multiplied both sides of the inequality by 4, which is a positive number.
In my case, I ended up reversing the inequality since I multiplied both sides of the inequality by negative 3, which is a negative number.
Good work! What we've just uncovered is the multiplication property of inequalities. This property states that if you multiply both sides of an inequality by a positive number, the order of the inequality will remain the same. On the other hand, if you multiply both sides of an inequality by a negative number, the order of the inequality is reversed. In mathematical terms, given any three real numbers, a, b, and c, where c is not equal to 0, if a is greater than b, and C is greater than 0, then AC is greater than BC. Otherwise, if C is less than 0, AC is less than BC. Of course, the same is true if A is less than B.
Ma'am, why should C not be equal to 0?
Let's see. Let's consider the inequality 4 is greater than 3. If we multiply both sides of the inequality by 0, what will happen?
Oh, I see. Both sides will become 0, so it won't be an inequality anymore.
That's right.
Ma'am, what if instead of multiplying, we divide the inequality by the same number?
Well, if you remember, A over C is equal to A times 1 over C. Like 2/3 is the same as 2 times 1/3. That means division is subsumed under this property, the same way subtraction is subsumed under the addition property. However, let's verify this just the same. Let's consider 8 and 6. Note that 8 is greater than 6. Now divide both sides by 2 and then by -2 and see what happens.
I'll do +2.
And I'll do -2. You're right, ma'am. It's just the same. The inequality reversed when a negative number was used as divisor.
It does look that way, doesn't it? Let's try one more inequality just to be sure. Give me 2 numbers.
Ma'am, how about -3 and 4?
Okay, obviously -3 is less than 4. Now by what do we divide this inequality?
Ma'am, how about 3?
Okay, we'll divide both sides of the inequality by 3 and then by -3.
I'll do +3.
I'll do -3. It happened again. The inequality reversed when we divided both sides by a negative number.